All right, so we've talked about angles, defined what that means, more or less, sort of. We've talked about it, there's different ways to look at it, different ways to measure the value of an angle. And we hinted at this idea of sector, we kind of talked about it a little bit. We're going to spend a little more time right now just focusing on this idea of sector and what does sector mean. So, the important thing to do is think about a circle as part of, or sorry, a sector as part of a circle. Right? So I've got this circle, and it has some radius, r. And the idea is, I start with some initial side, and I sweep out some angle here, theta, whatever that means. Then it's going to mark out a slice of this circle, or a slice of pi. And if I was an ant walking along the edge of that circle, then it's going to have some distance s that it goes. Okay, so if we take this sector out and look at it by itself, I can think of it in those terms there, right? And we found that there's a relationship between s, r, and theta. If we use the measurement of that angle theta is to be radians, then we get that formula right there. And what we've done is we've essentially used that to define what it means to be a radian. So 1 radian means that if I sweep out 1 radian, it basically means that I'm going to sweep out a distance r along that sector. Okay? So what does that mean? That means if I have a sector with an angle of 4 pi over 3, and s equals 2, so let's see, how would I draw that? So here's the important thing is if I have half a circle, that's a sector where the angle is pi. This is bigger than pi, so it's going to have to be bigger than that. So now my sector looks like that. There's some radius associated with that sector. And again, if I have a turtle or an ant that walks along the edge of that circle, it's going to move a distance s. So my relationship now then is s equals r theta. So 2 equals r times 4 pi over 3. I multiply both sides by 3. And divide both sides by 4 pi. I get that. And this is what? Going to be 3 over 2 pi is the radius. Okay? So the next question is what's the area of this thing? I want to figure out what's the area of a sector. Well, I'm basically going to go along these lines, that I know the area of a circle is pi r squared. I know the area of a half a circle is going to be 1/2 pi r squared. A quarter circle is going to be 1/4 pi r squared. Okay, and I can think of this now as, for a sector, the area is going to be pi r squared times whatever percentage of a circle I have. And I can think of this angle as giving me what percentage of the circle. Okay? So what do we get in particular? Okay. So let's rethink this. And if I do that, if I recast this, I want to know what's the area of a sector, or the area of this slice. I have some sector. I think of a full circle, so this I can think of as a sector where the angle of the sector is 2 pi, or 100% of a circle. Okay. And my area here is going to be pi r squared. And that's basically a full circle, or 100% of a circle. But notice in terms of this angle, a whole circle has an angle of 2 pi. So I can think of this as in terms of 2 pi divided by the angle divided by what's possible for a full circle. I'm going to be careful about that, because I could go around more than once. Okay. Now in terms of this picture here, what do we have? So I've got that angle theta, and I just want to know what's going on with this piece here. The fraction of the circle that I have is whatever that angle is, divided by the angle associated with a full circle. Okay? So this is the percent of the circle that I have. So going back and looking at this particular question here, this is going to be pi r squared times the percent of the circle that I have. But that is going to be my angle divided by 2 pi. Okay? So this expression right here gives me the area of this, and now I'm going to do a little algebra to clean that up. If I do that, what do I get? So this is going to be pi divided by 2 pi times r squared times theta. My pi's will cancel. So I have that relationship for the area of a sector. Okay. So let's look at an example, see how we can use this. So I've got a pie. I'm going to cut it into 8 pieces. And if I just look at the top of the pie, or the crust, if that's the way you roll, the surface area of that top of the pie is going to be 0.0088 meters squared. Period. And the question is what's the radius of the pie? So what do we have? We've got our pie. I'm going to break it up into 8 pieces. Okay. If I just focus on one piece of this pie, I have some angle theta there, r, and the edge, or the length of the crust on the outside edge, is going to be s. So let's see, I have the area. I know what that is. I can figure out what theta is because I know I've got a full pie, assuming, and I've cut it into 8 pieces. So it's basically each one is going to be 1/8 of a whole. So a whole would be 2 pi. So the angle associated with each of these pi sectors is going to be pi over 4. And I know that my area is 1/2 r squared theta. Okay? So what I'm going to do is I'm going to substitute these values into here and then solve for r. So let's see. So I have 1/2 r squared times theta is equal to the area. Let's see. Let me multiply both sides by 2. I'm going to multiply both sides by 4. So then 2 times 4 will give me 8, and now I divide both sides by pi. Okay, and now to get the value of r, I'm going to take the square root. And in this case, I don't have to worry about the negative value because it doesn't make sense to talk about a pi with a negative radius. And if I plug that in the calculator, that's around 0.15 meters, so that's a pretty big pi, and that's the best kind of pi.